Good morning, friends. So, in the last few lectures, we studied design up of the single plate clutch and multi plate clutch. So, that's why second type of the clutch, that is cone clutch, we will study in the today's class. Cone clutch. So, if the limitations of the space, then we can use cone clutch. So, this is instead of the single plate clutch or multi plate clutch, if power is to transmit or if more efficiently, so then we can use conical clutch. So, in conical clutch, some of the inclinations is required. So, such type of the cone. This is friction material. And this is cup. For lever mechanism. This is cone. This is a driving shaft, and this is plane driven shaft. So, this is key. So, input shaft means that is a driving shaft, that is the fixed, and this is the rotating, and this is cup is rotating, and this is friction material, and this is cone material. So, power is transmit from this input shaft to the key to this cup material, means this cup, and cup to this friction material, friction material to cone, and cone to this splint shaft. So, this is the transmissions above the power because above the friction materials. So, here is also in cone clutch so application will be limitations of space requirement. Cone clutch can be used. Next, so here's Important is the perfect alignment. Perfect alignment means the input shaft and output shaft should be strictly coaxial, because this is power is to be transmitted, that's why this should be strictly coaxial. So this is the main point that is to be considered during the running conditions above the cone clutch, means for the operation. So this should be strictly coaxial. Now, so again in cone clutch, two theories. So one is, first theory is the uniform wear theory and uniform pressure theory and uniform wear theory. So here's this pressure is a constant, pressure is constant. So this is uniform pressure theory. And in uniform wear theory, here's this is inner diameter, this is outer diameter, or you can say this is D1 and this is D2 and this is face width B and this is angle alpha. So this angle generally inclinations is 12.5 degree generally. So this angle is, inclination angle is 12.5. So this is D2 minus D1 divided by 2. So sin alpha equal to, you can say this is D2 minus D1 and divided by 2 into, because this is B, divided by B, or sin alpha equal to D2 minus D1 divided by 2B. So this is one another relation. So for uniform pressure theory, so here's FA equal to, so for uniform is this pressure is constant, pressure constant. So that's why here FA equal to pressure divided by, or this is pi by 4 D2 minus D1. Sorry, this P average equal to, this is FA. So that's why FA equal to pi by 4 D2 minus D1 square into average. And for uniform wear theory, so here's this pressure is maximum here and here this is minimum. So that's why P max equal to FA divided by pi by 2 into inner diameter d2 minus d1, and P minimum equal to EFA pi by 2 outer diameter, or this is 1, this is d2, sorry, right. So this relations we can use. Again T equal to, or this force, here is force acting, this force acting is, this is normal, and this force is the axial force. So that's why you can draw force diagram. This force is the this force is the normal force, this is axial force, and this is radial force. This force is the normal force, and this inclination is equal to alpha. So that's why this is also alpha. So sine alpha equal to EFA divided by EFN, or EFN equal to normal force equal to EFA divided by sine alpha. So try to understand this. Now torque equal to, so torque equal to frictional force multiplied by dm divided by 2. So that's why this frictional force mu into Fa into dm divided by 2. So this Fa equal to Fn divided by sine alpha into dm is outer diameter, inner diameter divided by 2. So by using this formula you can calculate the torque which is to be transmit, and again use this relations P equal to 2 pi nt divided by 60 into 10 to the power 6. So you can calculate this is torque in terms of Newton mm. Next, now, so this Fa is axial force required to engage the clutch, but so this is Fe dash, so this is force required So actually this is required to transmit the torque. So try to understand this, and this is axial force required to engage the clutch. So this Fe dash equal to So this is frictional force. And this is equal to Fn sine alpha plus F into cos alpha. So this is Fe equal to Fa sine alpha so this is force required to engage the clutch. So try to understand this Fa is the only required to transmit the torque. So because this is essential and force required because during the running conditions because of the speeds the power which is to be transmit and that is running conditions and that is to be hold at the same positions. So this force required engagement this is greater than Fa. This force required to engage the clutch this is greater than the force required to transmit the torque because we studied only force required to transmit the torque during the running conditions. So this is the axial force and this is the axial force required to engage the clutch. So we will see now problems related with the this cone clutch. So please note down today's first problem. A soft surface cone clutch must handle a soft surface cone clutch must handle 200 Newton meter torque at revolution per minute. The large diameter of the clutch is clutch is 350 mm. The cone clutch angle is CL. Six and so this is alpha given. The face width B is 65 mm. The face width B is 65 mm and the coefficient of friction is and the coefficient of friction is 0.2. Referring to figure determine first bit the axial force required to transmit the torque. So B bit, the axial force are required to engage the engage clutch, the average normal pressure, the average normal pressure P on the contact surface when the maximum torque being transmitted. Maximum torque being transmitted. And D, the maximum normal pressure. So this is average normal pressure and this is maximum normal pressure. Use uniform wear theory. So in this case, use uniform wear theory. So here's this inclinations is given 6 and 1/4 degree, and this is D1, and this is D2, this is B face width, and this is equal to 175. So here's solution, and this sine alpha equal to outer diameter minus inner diameter divided by 2 into B, or sine 6.25 inner diameter So this is outer diameter 350, inner diameter divided by 2 into 65. So outer and inner diameter equal to 350 minus 130 into sine 6.25. This is equal to 336 mm. Inner diameter equal to 336 mm. So that's why norm FA equal to so what is given? Torque is given. So first we will calculate torque. So 60 into 10 to the power 6 multiplied by P divided by 2 pi n T equal to. So sorry, this is torque directly given 200 Newton meter. So that's why this is 200 into 1000 Newton EMM. So next is torque equal to frictional force multiplied by dm divided by 2. So this frictional force equal to F into Fn into, so this is basic relation. So Fn equal to Fa divided by sine alpha and dm equal to outer diameter plus inner diameter divided by 2. So this is 1/4 0.2 and this is torque equal to Fa sine 6.25 into, this is 350 plus 336 divided by 2. So that's why this is first bit axial force required to transmit torque equal to 200 multiplied by 1000 multiplied by 4 into sine 6.25 divided by 0.2. So yes, into, right. Consider this is 2 and this is 350 plus 336 means 343. All right. All right. So 200 multiplied by 2 multiplied by sine 6.25 divided by 343 divided by 0.2. So this is 635 Newton. Newton. Second bit. Now the force required to the clutch. The force required to engage the clutch. And this is equal to Fn, engage. Fa divided by sine alpha in bracket sine alpha plus mu cos alpha. 635 sine 6.25 sine 6.25 0.2 cos 6.25. So this is total force required to engage the clutch during the running conditions. Cos 6.25 into 0.2 plus sine 6.225 divided by sine 6.25 multiplied by 635. So this is equal to 1795 Newton. So you can conclude that force required to engage the clutch, this is more as compared to force required to transmit the torque, because force required to engage the clutch means that is engage and transmit the torque, and transmit the torque means only that axial force required to transmit the torque. So in cone clutch, this construction is simple and easy to disengage the clutch as compared to multi-plate clutch or single plate clutch. So third bit. Now the average normal pressure. The average normal pressure means Fa divided by pi by 4 d2 square outer diameter, right. So this is 635 multiplied by 4 divided by pi 350 square minus 336 square. 635 multiplied by 4 divided by pi divided by bracket 350 square minus 330 square bracket close equal to 0.841 Newton per mm squares. So this is average pressure. Next is for maximum pressure. as you knows, fourth bit the maximum normal pressure equal to divided by pi by 2 into inner diameter. So actually this is pi r circumference multiplied by basic formula. This is d2 minus d1. So same you can write pi by 2 and this is d1 d2 minus d1. 635 multiplied by 2, 636 and this is 650. So if this is we got maximum that is greater than 0.08, means our answer is correct. 635 multiplied by 2 divided by pi divided by 636 divided by the difference is 14. Oh, sorry. So I consider this 350. This is 336. So I check now. 635 multiplied by 2 and this is 336 divided by 336 divided by pi and divided by 14. So this is 0 point slightly greater 8593 Newton per mm squares. So this is correct. Now next problems. A cone clutch. So if you have any doubts related with the theory or any chapters, you can ask me at any time. So you are free to ask me any doubts related with the any chapters of the machine design. So please note down next problems. A cone clutch with asbestos friction. A cone clutch with asbestos. So this is popular material for cone clutch. Friction lining transmits 30 kilowatt power at 500 rpm. The coefficient of the friction is the coefficient of friction is 0.2 and the permissible density of pressure is 0.35 Newton per mm squares. The semi-cone angle is so this is semi-cone angle alpha is 12.5 degree. The outer diameter is fixed. The outer diameter is fixed as 300 mm from space consideration space limitation. This is given. Limitation means consideration is also correct, but limitation given. Assuming uniform wear theory. Calculate the inner diameter the face width of friction lining the force required to engage the clutch. So for understanding purpose, I draw here this diagram. This inclination 12.5 and this diameter is 300. This is for data. So P equal to 2 pi nt divided by 60 into 10 to the power 6, 60 into 10 to the power 6, P equal to how much? This is 30 kilowatt and this RPM is 500. T equal to 60 into 10 to the power 6 multiplied by 30 divided by 2 divided by pi divided by 500. 572 957 Newton EMM. So in this case, P is not given. So torque equal to, so we will use basic formula mu into frictional force into dm right. dm divided by 2. So this torque equal to 572,957 mu into Fa divided by sin alpha d2 plus d1 divided by 2. Now Fa equal to, so which pressure given? Permeable intensity. Permeable intensity of pressure is, so that's why P max equal to, you can assume this is pi divided by 2 into d2 d1. Now Fa equal to 0.35 multiplied by pi by 2. This is d2 300 mm, I think, minus inner diameter. Now can we put this value of the Fa? By putting value of Fa in equation first. Suppose this is first equation. So that's why 572957 equal to mu equal to 0.2. Fa, instead of the Fa we are putting, this is 0.175 multiplied by pi into multiplied by divided by 2. So this is 2. Again we have to consider this 2. So that's why this is 4 by sin alpha. All right. And 57 multiplied by 4 into sin 12.5 divided by 0.2, 0.175. Why this is 0.175? So I consider this is right, and here this is 4. So what will maybe 0.2175 equal to 300 square minus I think this is correct. Right. Multiplied by 4 multiplied by sine 12.5 divided by 0.2 divided by 175 divided by pi. So I think I did some of the mistake. 572,957 multiplied by 4 multiplied by sine 12.5 divided by 0.2 divided by 0.175 divided by pi. So I am making some of the mistake. 572,975 multiplied by 4 divided by multiplied by sine 12.5 divided by 0.2 divided by 175 divided by sine pi 4511432 equal to 300 square, means this is 900 minus di cube or di cube plus 11,432 equal to 0. So I'll check my answer. All right. So inner diameter equal to, this is 220 mm. So this is your first answer. Second, now sine alpha equal to d2 minus d1 divided by 2 sine alpha. So this is 300 minus 220 divided by 2 sine, this is beta. Beta equal to, or b equal to 40 divided by so I will check that 300 or 200. This is 30 divided by 2 divided by sine. All right. So this is 270. So here's 30 equal to 69.30 mm. So this is required face width. Now force required to engage the clutch. So this is equal to Fn sin alpha plus mu cos alpha. So we request now Fn equal to Fa divided by sin alpha. Fa equal to 0.35 into pi by 2 multiplied by 270 into 300 minus 270. This is 30 multiplied by 270 multiplied by pi divided by 2 divided by 0.35. 4 right 4453. So this 4453 sin 12.5 20,574 Newton. So that's why 74 multiplied by sin 12.5 cos 12.5 cos 12.5 multiplied by 0.35 plus sin 12.5 into 11483. So this is equal to 11483 Newton. So this is your expected third answer. So that's why today I stop here because limitations of the time, and in the next class we'll see centrifugal clutch. That is the last type of the clutch. This is the third type of the clutch, centrifugal clutch. So automatically that is engage and disengage. So there is no requirement of the apply axial force required to disengage the clutch or engage the clutch. So that's why in the next class we'll see problems related with the third type of the clutch, that is the centrifugal clutch. So after that we can start the design of the brakes. This fifth unit last chapter is the brakes. So that's why today I stop here. Thank you.